How well do we understand the relationship between gravity and light? This question challenges our current comprehension of physics and proposes a re-evaluation of some fundamental principles. We're delving into the relationship between gravity, light, and their mathematical descriptions, particularly within the context of the McGinty Equation, or MEQ. A new perspective is being introduced on the speed of light, suggesting that it should be expressed in terms of acceleration and time. This gives birth to a novel equation, c equals acceleration times time. Additionally, a formula is being proposed that relates the velocity of gravity to acceleration and orbit time. The assertion here is that the velocity of gravity is determined by gravity's acceleration and the duration of an orbit. This yields an approximate value that matches the recognized speed of light. But how does this fit into the MEQ? Well, incorporating these notions necessitates a thorough assessment of their interaction with existing components, such as quantum fields and fractal potentials. The redefined velocity of light and its dynamic with gravity are a substantial departure from conventional physics. It prompts a re-evaluation of how electromagnetic waves behave within quantum fields and could impact the manifestation of fractal potentials. The revised velocity of light could fundamentally influence the behavior of wave functions in the MEQ, potentially altering the propagation speeds of wave-like phenomena and their evolution in space and time. Given the intimate connection between gravity and light, the modified MEQ would need to explicitly account for gravitational effects. To validate these proposed changes, rigorous mathematical derivations, simulations, and experiments will be required. Any modifications should align with established physical principles in appropriate limits. These proposed alterations could have far-reaching consequences for quantum field theory, potentially necessitating a re-evaluation of fundamental concepts and principles in light of this revised understanding of the interplay between gravity and light. If the redefined velocity of light and its altered relationship with gravity hold true, it would likely impact the compatibility of the MEQ with general relativity, warranting a re-examination of how these theories can be effectively integrated. It's crucial to emphasize that such substantial shifts in our understanding of physics would demand an extensive process of peer review, validation through experiments, and potentially a re-evaluation of existing physical theories. These proposed revisions represent a departure from established physics and would require thorough scrutiny before being widely accepted. The potential impact of these changes could be immense, reshaping the landscape of physics as we know it.